Good day, students. You are welcome to another class. In the previous class, you learned how to separate mixtures using distillation method, fractional distillation method, separating funnel method, centrifugation method, and sieving method. Today, we have a different topic to treat. But before then, I would like to ask some few questions. How do you feel each time you hear about acid? Do you get scared? Are you afraid that acid will burn your skin? Does acid really burn? Where can we find this acid? Are acid found all around us? Is acid found in our food? Can we find acid in our system? These and more questions will be answered as we proceed with this module. But don't forget to attempt your quiz. Don't forget to drop questions in the question box and do your assignments. But firstly, we would like to know the meaning of acid. What is an acid? An acid can be defined as a substance that produces positive hydrogen ion when dissolved in water. That reaction is known as ionization process. So let's see how acid dissolve in water. We have two equations on the screen. The first one is on hydrochloric acid. When you dissolve hydrochloric acid in water, it will produce hydrogen ion H+, and chlorine ion Cl-. So the hydrogen ion is a positive ion. Then we have triazo nitrate 5 acid. When dissolved in water, it will produce H+, hydrogen ion, and NO3, triazo nitrate 5 ion. So, we define acid as any substance that produces positive hydrogen ion when dissolved in water. We have two major classes of acids. These classes of acid are organic acid and inorganic acid. An organic acid is an acid that is produced from plants and animals. That is, they are natural acids. Can anyone tell us some examples of acids we get from plants and animals? Okay, let me help you out. Some examples of organic acids are lactic acid. We get it from milk. Then we have ethanoic acid. We get ethanoic acid from vinegar. Then ascorbic acid, also known as vitamin C. So where do we get ascorbic acid? Okay, ascorbic acid, we get it from oranges. Then we have amino acid. I'm sure amino acid is no longer new to you because you treated digestion of food in JSS 2, and I'm sure you have come across amino acid. So, who will tell us where we get amino acid from? Okay, amino acid, we get it from protein. Then we have the formic acid from ant sting. I'm sure you are surprised that ant sting produces acid known as the formic acid. We have other examples of organic acid. We have the citric acid from citrus fruit. We have the tartaric acid from grape. Then we also have the malic acid from apple. We have several examples of organic acids. So we are done with organic acid. Let's see the meaning of inorganic acid. Inorganic acid are acids that are prepared in the laboratory from mineral elements. So you see they are artificial acids that are produced in the laboratory when you combine elements together. So let's see some examples of inorganic acid. Some examples of inorganic acids are hydrochloric acid, tetraoxosulfacic acid, triazonitrate 5 acid, and triazocarbonate 4 acids. All these are inorganic acids. We can also classify acids as dilute acid or concentrated acid. When you say a substance is dilute, what do we mean? When a substance is dilute, what is the meaning? Okay. A dilute acid is a type of acid that contains large quantity of water. This acid cannot burn. In other words, the acid is not corrosive. Students are allowed to handle dilute acid because they are not corrosive. But for concentrated acid, dilute acid is the opposite of concentrated acid. So, what is the meaning of concentrated acid? Well, concentrated acid is a type of acid that contains little amount of water. The acid is corrosive. Students are not allowed to handle concentrated acid. When you say an acid is corrosive, it means that the acid can burn. By the time it touches your skin, it can burn the skin, it can burn clothes, can burn paper. So students are not allowed to use concentrated acid. So let's see some typical examples of properties of acids. Properties of acid. Acid has sour taste. When you say a substance has sour taste, I'm sure you know the meaning. It is not bitter, it is not sweet, but it has a sour taste. So all acids have sour taste. Acid reacts with base to produce salt and water only. We call that reaction neutralization reaction. On the screen, you have an example of such reaction. You have hydrochloric acid reacting with a base known as sodium hydroxide to produce sodium chloride, a salt, and H2O, water. This reaction is known as a neutralization reaction because the two products, salt and water, are neutral to litmus paper. That is, they are neither acidic nor basic. So acid reacts with base to form salt and water. The reaction is known as a neutralization reaction. Then, concentrated acid are corrosive. We don't handle it. We don't allow students to handle concentrated acid because they are corrosive, they can burn. Acid turns blue litmus paper red. We have two types of litmus paper. We have the blue litmus paper and the red litmus paper. So acid turns the blue litmus paper red. Acid reacts with metals to liberate hydrogen gas. On the screen, you have a typical example of such property. Zinc reacting with tetraoxosulfacic acid. Zinc is a metal. It reacts with dilute tetraoxosulfacic acid to liberate hydrogen gas. So you see the arrow going upward, showing how hydrogen gas is being released. All these are the properties of an acid. So let's quickly look at some uses of acids. I'm sure you know that acids have several uses. So, what are the uses of acids? Okay, acid is used for the production of baking powder. Tartaric acid is used for the production of baking powder and carbonated drinks. Your common Coca-Cola, Pepsi, 7-Up, malt, and other carbonated drinks are produced from acids. Do you know that most drinks that we take are acidic in nature? So, tartaric acids are used for producing carbonated drinks and baking powder. Then tetraoxosulfacic acid is used for the production of car battery, drugs, and fertilizer. So we see we have different uses of acids. Acid is very useful in our society. Then citric acid, an example of an organic acid, is used for the production of food preservatives and food flavor. Then we also have boric acid, an example of an organic acid, is used for the production of detergents, antiseptics, and glass. Then lastly, acid is used for the production of salt. We have finally come to the end of today's topic. So we can now define acid. We discover that acids are classified into two classes: organic and inorganic acids. You should be able to state 10 examples of acid and their uses. You should be able to list some properties of acid. You also discover that it's not all acids that can actually burn the skin. It is only concentrated acids that can burn the skin. So students are not allowed to handle concentrated acid. On this page, you have the concept question. You are expected to provide answers to the concept questions. So have a nice time. Take care of yourself. Until we meet in our next class. Bye for now.